Hi everyone, my name's Octavia. I'm the principal security engineer here at Prelude Security. I'm also a community specialist running the Discord live series, amongst other things. Our venue is really simple. Every week we bring out a guest speaker to come and talk about something InfoSec related or InfoSec adjacent. This week we have Sharon Goldberg joining us from BastionZero. Sharon, I'm really excited to have you here with us. Thank you so much for joining. And with that, I'll hand it over to you.
Okay, great, thank you. All right, so happy Thursday, everyone. Just let me start by telling you who I am, and then I'll get into my presentation. So I'm the CEO of BastionZero. We are based here in Boston. I'm one of the founders. My story is I started out as a telecom engineer in the early 2000s, working on like old, what was then novel stuff in networking and working with network operators. Then I actually started my PhD, and when I did my PhD, I got into cryptography. This was mid 2000s at Princeton, and kind of like right around when they were figuring out how to do TLS properly. So it was a really, really exciting time to be getting into cryptography. I was actually, as an engineer, not really able to be a full on cryptographer because most of them at that time were mathematicians or computer science theory people. So I ended up becoming a network security researcher and doing a lot of work with the ITF on protocols like BGP-SEC, RPKI, DNS-SEC, NTP, and things like that. So most of my academic career was in cryptographic network protocols and a bunch of standards work. I got into blockchain for a little bit, did a blockchain startup, and then got the hell out happily, no longer doing that. So, and that's a conversation if you want to have, which is a fun conversation to hear about my adventures in blockchain. And then we started BastionZero, and what BastionZero is, it's a tool for providing remote access to your back-end infrastructure, so to your servers, your databases, your Kubernetes clusters. And it uses a concept that my co-founder and I developed at Boston University, where I'm also a professor, which is the idea of instead of putting all your eggs in one basket or having one key to rule them all, we break up keys, break up control of access into multiple roots of trust. So that way you don't have a single point of compromise that if it's breached, your entire backend is breached. So a lot of the concepts in the product are actually related and like coming out of research that I've done in the past. But and I don't know how to use Discord, so if someone is saying something to me, Octavia, you've got to help me out because I just am a novice at this. Anyway, okay, so just jump in verbally because I can't. Okay, okay. Thank you. Awesome. Yeah, so basically like it came out of my research and with my co-founder, and what is interesting is that like when we started this company, we were thinking that the security model that we were working in was way too aggressive for what was really happening in terms of attacks and things like people were thinking about. And then over time, we realized that it's actually not too aggressive. It's actually right on in terms of what adversaries are actually doing. And so some of the stuff that, like the majority of this presentation is going to be a history lesson about different attacks that happened, some of them even dating back to 2001 when I was still in college. About how adversaries attack systems and in particular backend infrastructure, and what lessons we can learn about how to design systems that are not as vulnerable as the ones that were, attacked in the early 2000s, even though a lot of people still use systems that look like that. Okay, so I'm going to cover 5 different incidents. Fluffy Bunny, which is a really obscure. Does anyone know Fluffy Bunny? Because I know this group is like heavily infosec. Has anyone heard of them other than me? It's like a really old hacker. I actually gave this presentation at B-Sides, and there was one person there who was like, "Oh, I remember Fluffy Bunny in the 2001 era." Anyway, so this was like one of these attackers from back in the day. Operation Aurora, which was by China, not Petya by um, DigiNotar, which to me was like one of the watershed security incidents that like shaped kind of like my whole research career, which happened in 2001, a year after I became a professor, and SolarWinds, which we all know. So I'll walk through some of these and what we can learn from them. Okay, so that's the plan. Okay, so my company's called BastionZero. I'm obviously very interested in Bastion hosts. What is a Bastion host? It is a server you set up that stands in front of your other servers. And the thinking is that, when you want to control access to sensitive servers, you shouldn't just have all those servers connected to the public internet or exposed, or accepting SSH connections or whatever from all over the place, right? So the idea is if you have a Bastion server, you can set up your servers to only accept SSH connections from the Bastion. That will control, who's getting into your servers, and then you have a good place to monitor access to those servers and take them off the public internet, right? So that's why people have Bastion hosts. All right, so not now, Ellie.
Wait, what are you doing?
So anyway, what happened with Fluffy Bunny? So what happened with Fluffy Bunny was there was an attacker, and this was in 2001, where they compromised someone's machine. What they did was they actually replaced the SSH client that they were using with malware. The SSH client was now exfiltrating SSH keys to the attacker. And then when this victim actually logged into the Bastion host, the adversary was able to then compromise the Bastion host and also replace its SSH client with malware. And so as a result, they were just exfiltrating the SSH keys to all the servers behind the Bastion, and collecting all of those SSH keys as a result, right? So this was like a really interesting classic attack, right? Where we found that SSH keys are, if they're all sitting in one place, like this Bastion, then an adversary could just sit there and harvest all the credentials. And then what's interesting, of course, is that the Bastion is a single point of compromise, right? So my lesson here really is that there were like several things that in 2001 were best practices that are no longer best practices, right? Those are, don't give your users long-lived credentials like SSH keys, because if you do, and someone could steal them and use them a year later to attack you. And then second of all, like having all your keys accessible in one place creates a single point of compromise that's very attractive for attackers to go after, like a Bastion host. So Bastion hosts are very sensitive, and I'm sure that folks here are well aware if they've got Bastions in their network, those are a place where an attacker would love to be. And we've had attack after attack where attackers go after Bastions. The latest one that I know of was the Medibank breach in Australia that happened last year. Medibank was a health insurance provider in Australia, and the attacker got on their Bastions that were sitting in front of their databases and breached the databases that way. Okay, and of course in 2001 we didn't use MFA. Today we do. The idea here is what people, think about is that anytime you have a long-lived credential like a key or a password, you want something short-lived or some other factor like MFA to protect it. Okay, cool. So here's another one. So we all know what a VPN is. Traditional VPNs will use a long-lived credential that the user holds, and once they are able to get into the VPN, they can then access all of the targets that are behind the VPN, right? And so, here's a story that comes from Andy Ellis, the CISO of, sorry, by the way, the Fluffy Bunny story, that Bastion host was an Akamai Bastion host, and I got this story from Andy Ellis, who's the former CSO of Akamai. This is another Akamai story. Akamai is one of our investors, by the way, at BastionZero. So I have lots of Akamai connections here, but this is the Operation Aurora story. This is what happened to at Akamai. So we had an attacker that used spear phishing plus a vulnerability in Internet Explorer to actually get a VPN credential, and then somehow to get onto servers that were behind the VPN. And then actually they were taking their time. This was a state-sponsored attack. They were actually sitting in the network for about a year. Akamai didn't actually know that they were inside. But because they were behind the VPN, and at this time, this is a long time ago, they didn't have protection sort of to segment these servers away from each other. So once the adversary was behind the VPN, they were actually able to move around. And they didn't actually know at Akamai what was happening until Google found a command and control server that was controlling all of this malware that were on these servers, and then notified Akamai what was going on. And that's when they found them. They actually didn't know that they were there, so they were just sitting there quietly and like looking around. What they ultimately stole, that is known, is that they got on some financial reporting software, and they were able to find the lines of code in the Akamai software that was most valuable. So it seems like some kind of economic espionage attack that happened, and you can find writing from Andy about this back in the day when this happened. So this is like the classic, like, your VPN is not a good enough protection type of attack, right? Because what happened here was the assumption in 2009 was that, if it's behind the VPN, it's secure. And that's obviously a dangerous assumption, right? So don't base trust on network locations. Perimeter VPNs are not enough, and then segment your infrastructure. And so if you follow some of the what are they called? Executive orders coming from the White House right now. If you read these executive orders on zero trust and things like this, what they specifically say is, perimeter-based defenses are insufficient. So in 2009, we had VPNs, perimeter-based defenses, considered an acceptable sort of proxy for security. And now I think we know that it's not. And in fact, it's gone all the way to the point of like policy coming out of the White House, where they had the zero trust memo that came out in January of last year that really talks about like why this is not sufficient. And if people are interested, I can link you like my analysis of that zero trust memo that came out from the White House in January. I think it was actually, to me at the time, I was like, wow, that's really forward thinking. So, okay, can I take a breath here? Anyone have anything to say or anything before I go on? Should I keep going? Okay, I'll keep going. All right, cool. So my next story here is on single level domain administration. So Active Directory, I am personally really obsessed with Active Directory security. I don't know if people here are interested in this, but Active Directory breaches and ADFS breaches are really, really popular, and they've become more popular over the years. I've actually saw that in Poland they're offering a course on AD exploitation tradecraft, simply because Active Directory is so powerful, right? And why is Active Directory powerful? What it does is it actually controls your devices, it controls your servers, and you can have an admin credential that has the power to basically, rewrite or do anything it wants to the device, right? It gets root access on the device. And so because AD is so powerful, we know that attackers and ransomware and things like this will go after Active Directory. And so this actually, like something similar to this happened with SolarWinds, with Colonial Pipeline, and it also happened even before that with NotPetya. And these are actually probably like attackers that are somewhat related, or at least from the same country. So looking at this now, makes it even more poignant, because what happened was this was an attack on Maersk, the shipping company. The story goes that there was Ukrainian tax software that they were using to pay taxes because they were operating in Ukraine. And what happened was the adversary compromised the Ukrainian tax software. So it's almost like a watering hole attack. And when they were pulling from the Ukrainian tax software inside the Maersk network, they got infected, right? So this server here got attacked. And what happened was they were actually able to get the domain administration credentials that they were using across all their systems. And the part that gets really crazy was that they were actually using the same password to administer all of these Active Directory password was the same. And once they had that password, they were able to actually get on to pretty much everything else. And this is the story of, like, if you remember this story, this was the shipping giant whose all the computers just shut down. It was like one of those things where people were like pulling laptops out of the wall, like unplugging things so that they wouldn't get bricked. And that's what happened. They very, very quickly like bricked all of their computers, and they just had no computers anymore, effectively, at Maersk. And this was like, you read the story from Wired that I can also link you. It's an incredible it's an incredible story. They ended up having to be offline for something to like 3 to 4 weeks before they could have any like computer systems up. They actually had to like put shipping containers on airplanes so that they could actually ship them to where they were going. Like, it just completely, damaged their systems. And it really came from these domain credentials, like these administrator passwords that were the same and were attacked. So, things to think about. AD admin or Active Directory in general, really significant point of compromise for systems because it's so privileged. Admin credentials, here were exploited. The admin credentials here had overbroad scope, so they were being used in too many places, which, is crazy, but was the case in 2017. So fixing this would have made this less terrible, but at the same time, like, Active Directory is still really, really valuable to attackers, and it continues to be attacked over and over again. And so, that's another piece to just think about. If you do have that kind of AD in your environments, it's a really valuable point of compromise. Other things that we can learn and we can segment your infrastructure so it's not all accessible with the same credentials. And then, of course, software supply chain security, right? So thinking about, what software you're using and how you're using it. Although I have to say, like, looking at this one, like a watering hole on a tax software, it's crazy. Like, that's the kind of thing that that's really hard to plan for. But I do think that some of the other components here around segmentation and protecting your domain credentials and your Active Directory is feasible, right? It's really going to be really hard to make sure that every sort of software that you use on all your computers is going to be not going to be attacked or containing some kind of malware. It's really hard to avoid that. Okay, so let me take a break. Any thoughts, questions here on any of the stuff that I brought up here?
So just a quick question. You mentioned at the beginning of the NotPetya section that Poland had developed a course on AD tradecraft, and I'm sure that folks here would be interested in something like that. So is that like a university course? Is it some type of InfoSec certification?
I don't know. I have to see what exactly it is. It's one of these InfoSec 3-day certifications that I just found it so interesting because it was like a 3-day course on AD exploitation tradecraft. Gotcha. Which just shows you to the like how far this has gone, that there's a 3-day course that's being offered to like penetration testers and stuff. It's not like an underground thing. I think it's like a legitimate white hat thing.
Yeah, that sounds about right. I know that I've taken at least 2 courses that had an AD section. I haven't seen one dedicated to AD, but it doesn't really surprise me for exactly all the reasons you've stated. So.
Yeah, I actually think it's like it could even be happening right now or in a couple of weeks. Like it's imminent. I'll look it up and I'll share it with you.
Yeah, I'd love that. Thank you.
Okay. So, the things that we saw, and I don't know, I don't have a slide on this, but the things that we saw so far really illustrates the principles of what people are trying to do when they talk about zero trust. And I know that everyone here has heard zero trust too much and it's been destroyed by marketers. Like, I get that, but it is a real thing. And when I talk about zero trust, I talk about the NIST 700 and something specification. I always forget the number. It ends in a 2. Anyway, there's this NIST specification that talks about what are the principles of zero trust. And some of the things that are in that specification are, don't give your users long-lived credentials, perimeter controls like VPNs and things like that are insufficient, right? Users should authenticate anytime they want to access something, and they should be authorized to access that thing, which means you don't give overbroad privilege, right? You have like very scoped privilege. All of that is like really, really closely tied to what we saw with the Bastion host attack with Fluffy Bunny, right, where there were long-lived credentials that were exploited, and the attack with Operation Aurora, where the attacker got behind the VPN and was just able to move laterally because there was really no authentication or authorization that was controlling where they could go once they were behind the VPN. So all of that stuff really drives the zero trust principles. But I still have like a little bit of a beef with some of the what people are calling. Sorry, is there a question? Okay. I'll keep going. So, right. So basically, right, like all of this gives rise to these zero trust principles, which really are, thinking about your users. Are you giving them time limited, least privilege access to specific targets rather than, standing access to all the targets without segmentation? Are you checking that they're authenticated and authorized every time they want to access something? Or are you using just like a perimeter VPN approach with long-lived keys, right? That's the opposite of zero trust. So all that stuff is really serious, good principles we should use when we think of access to infrastructure. And I don't think that anyone would argue that these are like what we should all be doing and what we should all be thinking about. But what is interesting is how we actually go about implementing zero trust, right? So, this is an example of I made a yellow box to symbolize the zero trust system. And what's happening here, we have the user Alice, and she's accessing, she wants to access some server as root. She goes to the zero trust system, she asks for access. If it's granted, she gets some kind of like token of some sort that goes to the target, and if it validates, then the target will let her in. So that does achieve zero trust because the short-lived token is short-lived. She's having to authenticate to specific targets and potentially even a specific account, like a root account on the target, as opposed to something else, right? So that's all great. How this is actually implemented, like what is that yellow token? That yellow token can be a certificate authority, it could be an SSO provider, it could be a proxy that, for example, has access to a vault, which has credentials for all of the targets, and so you would authorize to that proxy, it would agree that you really should have access, and maybe it even brokers the connection for you to the target. So you would change the drawing that I have here to actually have the user's connection go through the proxy, right? So that they are, getting access without getting the long-lived credentials to the target, right? So that's the way that these things are typically built. So again, like here's a picture of, for example, how you might do zero trust with a certificate authority. The yellow box could be a CA, a certificate authority, and the user authenticates to the certificate authority. And if that all works out, she gets some kind of short-lived certificate that lets her access the server, right? And so that's really good because the certificate may only live for like a few hours. And so, if she gets compromised, the theft of that certificate is not a big deal because it's not good anymore after 2 hours, right? So the attack window has been reduced. So that all follows the principles of zero trust. All right, but now I'm going to turn this around. Okay, and I'm going to tell you that I hate certificate authorities a lot. And how many people hate certificate authorities on this chat? I don't know if there's a way to like vote, but yeah, I really hate them. And actually, when I told you that I started out as a researcher, my whole line of research that I started, 10 years ago at Boston University was around avoiding all the risks associated with certificate authorities, because certificate authorities, there was a major certificate authority breach in 2011, which was 1 year after I became a professor. And so it had a huge impact on me. So do people remember this? Did you know, Tar? All right, no one's talking, so I'll just mute myself. It doesn't ring a bell to you? Wow, okay. Is that like the consensus here that people don't know this incident?
Haven't a clue, mate.
Okay. So I'm glad I've got you here because you should know this. This was a really big moment, I think, in internet security. So if you haven't seen this before, let me show you what happened. So in 2011, there was a certificate authority called DigiNotar. It was the Dutch CA, so it was serving like properties in Holland, like the RMV, like the motor vehicles, the government, all sorts of like local, government entities and local companies and things like that. So it was a local certificate authority. But if you know how TLS certificate authorities work, this was this was the web PKI, right? This is the TLS PKI. The way that it works is that certificates in the web PKI are not scoped to a particular domain. So just because this was focused on the Netherlands, it could still, even though it was focused on the Netherlands, there was nothing in the system stopping this certificate authority for issuing certificates to any property on the internet, like google.com, right? It could issue certificates to anything it wanted, BastionZero.com, anything it wanted, right? There was no limit. It's not like the CA's fault. This is just the way the web PKI is designed, and it is still designed today, by the way. So what happened was an adversary actually hacked into the DigiNotar CA and was able to compromise the signing key of the certificate authority. And then the next thing they did, they actually started issuing certificates to themselves. And it's known that they actually issued certificates for Google, where the key that was certified in the certificate, if you can see in red, you see attacker pub key. So basically the attacker put their own key in the certificate and claimed it was Google's key. And because they could do that, because they did that, they were able to actually intercept all, they could do a TLS man-in-the-middle attack. Basically, they could decrypt TLS sessions because they would impersonate the Google server using the certificate and then be able to decrypt the connections and then pass them on to the real Google. So they could actually man-in-the-middle Google connections, read the communications, alter the communications, and basically break the security of TLS. Does that make sense, what I explained? Tavia, did that make sense?
That makes sense, and I'm actually a little shocked that A, I haven't heard of that, and B, that root CA security is so janky because it implies that if you just operate a root CA in, let's say, maybe like a hostile country or something, you can do all of this stuff anyways. Is that correct? Or
Yeah, well, so I could spend hours talking about CAs because I spent a bunch of time doing research on CA security. Yeah, so the CAs are there's a lot of them. The really weird thing about the web PKI is that there's a lot of CAs. Their scope is not limited to the country that they're associated with. You can imagine the CN NIC, like the China NIC, when they wanted to have a CA trusted by browsers, there was a lot of drama there. I actually don't even remember where that landed or whether your current browser actually trusts the Chinese root CA. But yeah, there are a lot of root CAs. There's at least 40, if not more, that all have the authority to issue certificates for the entire internet. So it is crazy, right? Like, think about this. This is crazy. And this was the state of the world in 2011. And this actually led to a lot of work in the community of figuring out how do we deal with CA security. Because, this is insane, right? You have some crappy Dutch CA that gets compromised, and as a result, all these properties that have nothing to do with the Netherlands are breached. And that's what happened. And that actually happened. And so in this period of like pre-2013, there were like quite a number of CA breaches, and this was the worst one. So you look at this, you can look at this in Wikipedia, and you'll see sort of the description. What they ended up doing was they were decrypting the internet communications of Iranian citizens. And I still don't know who did this. I actually asked on Mastodon and Twitter, like, does anyone know who this was? And it's not clear even who did this attack. But what happened after this, right? What happened after this was that there were, we learned that CAs are, a single point of compromise over broad scope is really dangerous. There was a huge effort in the community to improve the security of TLS, which all rests ultimately on the security of CAs. And as a result, we got certificate transparency, which is an IETF standard that is currently used. Like right now, your browser's using certificate transparency. And what that does is it creates a log of all the certificates that are issued for a particular domain, and that allows the owner of the domain to audit certificates that have been seen on the internet. So if anyone issues a weird looking certificate for your domain that is unexpected, you'll be able to see it, and you'll be able to notify that was an attack, right? So now we basically solve this problem using visibility into what certificates are issued. as opposed to actually solving the problem of CAs. So we still have the problem of CAs. There's also a lot of like, management of what routes are being trusted, how you run CAs and the security of CAs and what CAs are going to be trusted by your browser. I've actually, by the way, met the people who make the decisions of which CAs run in your browser. I met them last December, which I thought was just like really incredible. They just look like regular people who make these decisions.
That's wild.
It's wild, yeah. It's Google and Microsoft. I met the Microsoft person and I met the Google person, the Chrome person.
That's so fun. And just before you move on from the CA stuff, there was a question in the chat asking about your prior research on CAs and if that's published somewhere where they would be able to go and read it.
Yeah, so I never actually published on TLS CAs. I was adjacent to this, so I don't have publications on TLS CAs. I have publications on BGP CAs, so the ones using in the Borderware Gateway Protocol for routing, where I was really worried about the introduction of CAs to protect against BGP hijacks and the way they had set up the security of the global internet routing protocol, BGP, is one of the areas that I worked on, starting 2006 is how long I've been working on that stuff. And one of the ways that they were securing that, against IP prefix hijacks was to introduce a certificate infrastructure called the RPKI. And I was really worried that the way they were doing it was going to lead to attacks similar to DigiNotar, and I have a bunch of work on that, so I can also share that with you as well. But like, you have to think of me as someone who has hated CAs for more than a decade. And what drives me crazy, again, to speak plainly, is that when I look at all these zero trust systems and you look at what people are doing, they're like, look at us, we have a SSH certificate authority, or we have a short-lived certificate authority that issues certificates to you to provide you with zero trust access to whatever it is that they're providing access to. And I really hate this, right? Because it's like what you've done is you've said, okay, we're not going to trust users with credentials anymore, so we're going to put in a CA, right? Your own little private CA that you're going to either self-host or you're going to outsource to us, right? Self-hosting a CA, that's a huge target for adversaries, right? But people will do that and will sell that to you now as zero trust, right? Or they'll ask you to trust them to host a CA for you, which again is like a single key that if compromised will compromise all of your infrastructure, right? But that is what's considered like cutting edge zero trust technology, or at least, kind of before we started in this space. And to me, that was like the opportunity to start the company basically was because I had been thinking about CAs since 2011, and people are still trying to sell things as zero trust with CAs, and to me that's not really zero trust, that's 100% trust on the CA, right? If that's what's granting access. So just kind of going back to this picture, right? This looks really good. Sorry, the CA picture, this looks really good because the user doesn't have any credentials anymore, but the problem is that the CA has all the credentials, and we know that people attack CAs. Okay. Anyway, so any more thoughts on that or any more questions on CAs? I can talk for hours on CAs if you want me to. All right, I'll keep going. Another way that people like to think about controlling access or in a zero trust setting is with a single sign-on with SSO providers. And in that case, you may have someone, logging into the SSO provider, the identity provider, and either getting a SAML token or an OIDC token that is then, the target will, sorry, let me go back to my slide. Get their SAML token or their OIDC token, depending on what protocol is used, and based on that, they can actually log into the target, and that is using SSO provider as the point of control in making all these decisions. The problem is, right, SSO providers, again, are a big target for attackers, right? So, I can also mention, and I think everyone remembers, Okta is regularly attacked and breached up to a point. I think I would say about Okta is that they do get attacked quite often, and we hear about Okta breaches. They're pretty good, actually, at containing the attacker and segmenting where they can go. But it is something to definitely consider about SSO providers, whether they are whether they are going to actually provide you with like the security that you expect if you put 100% of your trust on the SSO provider. And so, the other example that I have is the SolarWinds example. And everybody, talks about SolarWinds when they talk about how the attacker actually got into the network. But the part that I want to talk about today is what the attacker did once they were inside. And with SolarWinds, once the attacker actually got in to the environments that they were attacking, what they did was they went after Active Directory, right? AD servers. And what they did was they were actually what was called, I think, a golden SAML attack, where they actually were able to steal the key that was issuing SAML tokens, and then they could issue SAML tokens to themselves. And because they could do that, they could now basically access anything that was trusting the AD as a SAML provider, and they could go anywhere. So that's how they moved laterally. And like this type of approach, this is the AD tradecraft attack. This is why people want to do the AD tradecraft attack. When you read about an attack and you hear lateral movement, in an attack, this is typically what's happening. And I talked to someone at CISA, CISA, the government agency, and he told me that like when you read, he's one of the people who responds to these incidents when they're like the big incidents that go all the way to the federal government. And he was telling me that like when you read about these, the postmortems often talk about how the attacker infiltrated the system, and that's where sort of like all the discussion about zero trust goes. But the actual next step is like actually compromising a point that's a centralized point of control that has all the credentials and all the privilege, which is something like your AD server. And so again, like I would, my point here is like this type of architecture, these types of architectures, if you have overbroad scope for an authority, or if the authority has overprivilege, or if it's just really the root of trust, if it's the root of trust for the entire system, then it's a very attractive point of compromise for attackers, and that's what they will go after, because that's how they can quote unquote move laterally. That's what move laterally means. It means you have the credential that lets you get into everything because you've compromised basically the system that controls access to everything, something like a domain controller or an Active Directory, things like that. All right, so these are really the principles that I wanted to show you. I also wanted to think a little bit with you about MFA, because a lot of times when everything I'm showing here has to do with like theft of credentials. But when we talk about the SolarWinds attack, you might ask yourself, like, would MFA have helped? What could MFA do, right? And in the SolarWinds attack, my question for you is, if the user is performing an MFA, would that have actually limited the risk associated with the SolarWinds attack? Yes or no? Nobody's talking, but I'm hoping that you'll say something in the chat or do something.
So just a reminder, folks, you can unmute yourself and chime in. And if nobody wants to say yes or no, I have an opinion. I'm happy to share.
Thanks, Octavia.
I'm gonna go with no. And do you want me to guess why that is?
Yeah. Please do.
So like, even with like MFA, you still have a single point of failure in your AD server, and all you really have to do is just spam MFA authentications until some admin says LOL and just hits the button to approve it. Which
that's a whole other presentation that I can do. That's my whole MFA presentation. I have this presentation that I've been giving at DevOps Days, where I'm trying to teach like DevOps folks how to think about MFA. But yeah, like this isn't actually a spamming attack. Like this, it's spamming or no spamming is not the point. The point here is that the SSO provider controls the key that issues the SAML tokens. And so if you can steal the key that issues the SAML tokens, it doesn't matter what the users are doing. It doesn't matter how you're doing MFA, because the MFA just goes to the same system that's issuing the SAML token. So if you've stolen the key for the SAML token, for issuing the SAML tokens, it doesn't matter that you performed MFA, that the users performed MFA. But there is a way that MFA can help, right? So what I'm showing here again, the adversary stolen the key for SAML token signing, and so it can create its own SAML tokens for whatever it wants, and then you're sunk, right? The thing is, though, that there is actually a way that MFA can help, and it really has to do with how you set things up. And so like a thing that you can do, and I don't know if anyone on this group has ever done or ever seen, like let's go back to 2010 era. You may have had a system where you had an SSH key and you also had or maybe you had an SSO into something, but then you also had some sort of YubiKey or some sort of Linux PAM module that was actually asking you to do MFA separately, that was like living on the server, right? The question is, like, if you want MFA to save you, you need to make sure that the MFA is independent of the entity that's actually issuing the SAML tokens, right? And this is like in this picture, maybe you can see it. There's a yellow circle and an orange circle. The orange circle is being issued by the MFA provider, and the yellow circle is being issued by the SSO provider. So if you actually authenticate against independent roots of trust, then a compromise of one doesn't lead to a compromise of another. And this, the spoiler is this is what we do at BastionZero. But like a lot of people have built systems like this, right? You may have some sort of like VPN provider that gates access, and then you have an additional like YubiKey or something installed on individual servers, right? Those are separate systems. They're independent roots of trust, and they have to be authenticated to separately before you can gain access. And so that's a way to like limit the risk associated with having an overprivileged authority or a single point of compromise that really can allow you to access everything, because what the servers are doing in this example is they're actually expecting both the SSO provider and the MFA provider to grant them access. And so that's what we do here in BastionZero, which is to have like our system doing an MFA that's independent of your SSO provider, and then both of the tokens running through our system and being delivered to the target and being verified by the target. So with what we do is we plug into OIDC with your identity provider. We get that token. If the user properly authenticates with MFA and also is authorized to access something, we grant them an additional signature that goes to the targets, and that they verify, the targets being the servers, they verify that that is valid, and then they grant you access. And we do this for servers, Kubernetes clusters. We're going to have Windows and RDP very soon, databases, and all sorts of backend infrastructure that you may have. Okay, so like the concept here, and what I'm trying to say is that like zero trust, the first set first set of maybe let me go back to the beginning. When the first set of incidents that I was talking about, the Fluffy Bunny, which was the Bastion host attack, the Operation Aurora, which was the moving behind a VPN attack, and the NotPetya, actually maybe the first two, really give rise to these zero trust principles, which are about not having users have long-lived credentials and unfettered access once they're behind a VPN, right? But once you have zero trust, I think it's also important to consider like what is this zero trust system that you've built, because if what you've built is a certificate authority or something where you put 100% of trust into your identity provider like Okta, then you may have to be waking up in the middle of the night if Okta was breached, right? And you don't have another gate to control access to whatever is important back there in your infrastructure. So those are some of the things that we thought about when we were building this, and generally just like incidents that are good to know and to keep in mind when you're thinking about the security of like a certificate authority or an SSO provider. And last thing I wanted to say was so I don't like this slide anymore. I actually like what I just said, so ignore this. And that's me. I am on Twitter, but not really anymore, and more on Mastodon, and actually on LinkedIn a lot these days. So please, please reach out and connect to me on any of these. My last name is Goldberg, Sharon Goldberg. So please just find me on LinkedIn or on Mastodon, and I'd be glad to chat more. And I'll also provide like links to the Storied and Wired that I mentioned about NotPetya, some of my research on CAs, some of my friends' research on CAs, and the DigiNotar incident, so you can have a look at that. So yeah, that's it. Thanks.
That's awesome. Thank you so much. Also, another fellow Mastodon user, which is nice.
Yeah.
So I have a lot of questions, and I think a bunch of them are actually about the technology. To be candid with you, I think this is really the first time somebody's presented something on zero trust where I didn't roll my eyes immediately. This actually looks fantastic. The burning question I have, and that everyone else probably has too, though, is like, let's hear your blockchain story, because it sounds interesting.
You have to turn off the recording if I'm going to tell you the blockchain story. Oh. I'm serious. I'll tell it, but you've got to turn off the recording.
Yeah, sure. So actually, why don't we maybe see if anyone else has other questions first, and then we can cut out the recording at the end, just so we can just so the video makes sense.
Awesome.
I'll
Yeah.
just open up the chat window. Yeah, so there's a question in the chat if you're going to link the slides. If you want to share those on GitHub or something, I'll make sure that we can post them on our YouTube as well.
Sure. Yep.
Cool. Okay, so one of the things you mentioned is that you have the separation of duties between MFA. You also talked about kind of next steps, which would include like databases and other technologies. Do you kind of have a roadmap for which technologies are a priority, and kind of like how do you think about prioritizing them? Is it based on customer needs? Is it based on centralized risk? Like some systems just tend to be more sensitive than others, or what are your thoughts on that?
Yeah, okay, that's a really good question. So here's how we think about this. We started with server access and SSH keys, and things like control of access to servers. And the reason that we started with this is because compute is really sensitive from a security perspective, in my opinion. And this also holds for Kubernetes clusters, because Kubernetes clusters are the new kind of computer, right? Clusters are the new computer, and any, if someone tells you that they're running infrastructure as code and they're using Kubernetes, right? Like the Kubernetes system is basically your new server. So in all of those cases, I think compute is really sensitive, and I'll tell you why. Let me give you one of the examples that really motivated me and my co-founder Ethan Heilman to start BastionZero. So in our blockchain company, we had an HSM, a hardware security module. And inside that HSM was a key. It was a Bitcoin key, right? For signing transactions in Bitcoin. And that Bitcoin key, if stolen, it would have been horrible, right? So we would have put it in we were putting it in an HSM because we didn't want anyone to steal our Bitcoin key, because if they did, it would be horrible. Now, the problem with an HSM is extremely dumb, right? HSM will sign whatever you ask it to sign. It will not expose its key because it's like, happily hiding inside the hardware, but it will sign whatever you want. And so if you have a server in front of the HSM that is trusted by the HSM, that HSM will just sign whatever the server asks you to sign. And so, whoever has access to that server basically controls the HSM, right? Does that make sense? So, my point is that compute is really sensitive because whatever is behind that compute trusts the compute. And so if the compute is compromised, whatever else is there is compromised next. So to me, wherever you're running your compute, you need to make sure that's super locked down, because anything that's behind it that isn't a security group that trusts that compute is going to be breached if the compute is breached. So that's why we started with things like servers and Kubernetes clusters. And that's really where I think the first place people need to think about is what is their compute, what compute has access to, and how are you securing that access? I think, then after that, really passwords is another piece, right? So you have database passwords. How are you distributing those? A lot of companies will give the passwords to their production databases to their engineers and have them sit on their laptops. We all know that database passwords are long-lived because databases are not smart enough to have short-lived passwords, so they have long-lived passwords. And you'll find a lot of organizations that have database passwords on people's devices, just on your laptop, right? If you're a DevOps engineer or a data scientist, right? And they're kind of like, it's okay because we gate this behind a VPN, right? It's not okay, and it's not good to have database passwords on your on your users' machines, and that's the next problem that we're solving. We're actually dropping our feature release for database password elimination in a few more weeks. I shouldn't really say that, but anyway, we are doing that. That's not the formal announcement, but that's a piece that I think is really, really important. So really, we started with the compute, but there are also the security of your databases where your sensitive data is living is really important. And if you kind of go and audit what you're doing, you'll possibly find that the database passwords are in a lot of different places, potentially on different compute elements, and also potentially on people's laptops, which is not good. So, so that's the second thing I would really think about when I think about access.
Yeah, it wouldn't surprise me to find that is the case. Having those passwords just
It's
leak.
the case.
I-
Yeah, it's just really hard to like manage them because the databases are not designed to have systems in front of them that create short-lived passwords, right? It's just not how they're built. It's not what the database vendors are focused on.
Okay, so speaking of like system design and I guess maybe like network architecture more generally, there are a lot of bad practices in Active Directory. I've seen a lot of organizations that really just are doing some of the worst mistakes you could imagine. So like a system like this that starts to kind of decouple responsibilities. What sort of challenges do you face implementing them in those environments? Is it a prerequisite that you must first have your AD set up in like a reasonable way, or do you help kind of like unwind that as you migrate them over to like a sane credential management or secret management system?
Yeah. So we don't use ADFS at all in BastionZero, and we don't require anyone to have Active Directory. What we do is we integrate with your identity provider, and it could be anything. We use, well, not anything. We support 5 today. We support Google, the G Suite IDP, Azure AD as an identity provider for humans, Okta, OneLogin, and KeyCloak, which is a self-hosted identity provider that some places like to use because it's on-prem. You can host it yourself. So we use that, and that's where our identity comes from. And then we use like BastionZero agents to create identities for machines that will then phone home to our service and identify themselves, and then we can connect to them that way. So we don't actually use Active Directory. Now, what's cool about this is like these machines are phoning home to our servers and connecting that way. But like if you look at this picture, we don't allow login into a machine unless you have both the credentials from your identity provider and from BastionZero. So both the yellow circle and the orange circle that you can see in the picture. So that means that our system doesn't actually have the ability to log into our customers' targets, because the only way to do that is if you actually have a valid user logging into the identity provider like Okta or whatever it is. And so even though we are setting up the connections and proxying them, we don't actually have access ourselves, because access is granted via an authenticated channel that we can't create on our own. So yeah, that's the way that we deal with this type of stuff, because a lot of organizations, more modern ones, don't use ADFS, but they do use SSO, right? You do have SSO in most organizations, and you know, best practices to move to SSO. The reason that's best practice, by the way, I know everyone's rolling their eyes at this zero trust statement, but the reason best practice is SSO is because that follows the principles of zero trust, right? Using your SSO is really a zero trust approach as written in the NIST guidelines, which is like around short-lived credentials and tokens and things like that.
Thanks. I had misunderstood that, so thank you for clearing it up.
It's not like anyone's helping, by the way, in this industry to help you understand.
Yeah, no kidding. So I'll put out like one last call for questions. I mean, folks, don't be shy. No question is a bad question, to be honest. But if there's nothing, and we'll give it maybe 1 minute here, I think I'll stop the recording, and I'd love to hear the blockchain story.
Oh, the blockchain story.
So let me just check the chat and see if we've got anything in there. I see one person typing. We'll just wait for them to finish. They're saying that your talk was awesome, and thank you. Okay. And I will echo that sentiment. This talk was fantastic. And Sharon, thank you so much for joining us. It's been wonderful. I'll end the recording in a moment. I don't know if you want to say any final words before I do so.
No, BastionZero.com. Please come visit, and you know, we'd love to talk to you if you want to learn more.
Wonderful. Thank you.